Today we're going to talk about random phenomena or probability. A random phenomenon is a situation in which we know what outcomes could happen, but we don't know which particular outcome did or will happen. The probability of an event is its long-run relative frequency. While we may not be able to predict a particular individual outcome, we could talk about what will happen in the long run. For any random phenomenon, each attempt or trial generates an outcome. Something happens on each trial, and we call whatever happens the outcome. These outcomes are individual possibilities, like the number we see on top when we roll a die. Sometimes we are interested in a combination of outcomes. For example, a die is rolled and comes up even. A combination of outcomes is called an event. When thinking about what happens with a combination of events, things are simplified if the individual trials are independent. Roughly speaking, this means that the outcome of one trial doesn't influence or change the outcome of another. For example, coin flips are independent. The law of large numbers says that the long-run relative frequency of repeated independent events gets closer and closer to the true relative frequency as the number of trials increases. For example, consider flipping a fair coin many times. The overall percentage of heads should settle down to about 50% as the number of outcomes increases. The common misunderstanding of the LNN is that random phenomena is supposed to compensate some for whatever happened in the past. This is just not true. For example, when flipping a fair coin, if heads comes up on each of the first 10 flips, what do you think the chances that the tails will come up on the next flip? Thanks to the law of large numbers, we know that relative frequencies settle down in the long run, so we can officially give the name probability to that value. Probabilities must be between 0 and 1 inclusive. The probability of 0 indicates impossibility. The probability of 1 indicates certainty. When probabilities was first studied, a group of French mathematicians looked at games of chance in which all the possible outcomes were equally likely. It's equally likely to get any one of 6 outcomes from a roll of a fair die. It's equally likely to get heads or tails from the toss of a fair coin. However, keep in mind that events are not always equally likely. A skilled basketball player has a better than 50-50 chance of making a free throw. In everyday speech, when we express a degree of uncertainty without basing it on long-run relative frequencies, we are stating subjective or personal probabilities. Personal probabilities don't display the kind of consistency that we need probabilities to have, so we'll stick with formally defined probabilities. 2 requirements for a probability. A probability is a number between 0 and 1. For any event A, 0 is less than or equal to the probability of that event A less than or equal to 1. The something has to happen rule. The probability of the set of all possible outcomes of a trial must be 1. The probability of S, which is the set of all possible outcomes, is equal to 1. The complement rule. The set of outcomes that are not in the event A is called the complement of A, denoted by A to the C. The probability of an event occurring is 1 minus the probability that it doesn't occur. In other words, P of A equals 1 minus the probability of the complement of A. In most situations where we want to find a probability, we'll use the rules of combination. A good thing to remember is that it is easier to work with the complement of the event we're really interested in. Beware of probabilities that don't add up to 1. To be a legitimate probability distribution, the sum of the probabilities for all possible outcomes must total 1. So let's look at some examples. List the sample space and tell whether the outcomes are equally likely. You have a family that has 2 children. Record the genders in order of birth. So you have boy, 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 girl, girl, boy, girl, girl, and they're all equally likely. The plastic arrow on a spinner for a child's game stops rotating to a point at a color that will determine what happens next. Determine whether the following probability assignment is legitimate. So you have red, yellow, green, and blue with its probabilities. The answer is it is legitimate because they are all between 0 and 1 inclusive, and that their sum equals 1. A fair coin has come up heads 10 times in a row. The probability that the coin will come up heads on the next flip is 50%. It doesn't matter what happened in the past, a fair coin still has a 50% chance of coming up heads. This is called an independent event. In a survey of American women who were asked to name their favorite color, 19% said blue, 19% said red, 16% said green, 11% said yellow, 14% said black, and the rest named another color. If you pick a survey participant at random, what's the probability that she named another color? The answer is 0.21, and how I came up with this is I added up the probabilities that were given, and I did 1 minus them. This is called the complement. So 1 minus all those probabilities equals 0.21.